Now, today we want to start looking at a new type of transformation, which is called central symmetry. Now, central symmetry always involves a point, so central symmetry in a particular point. I'm going to start by showing you how to do it, and then we'll write down some notes on what a central symmetry looks like, and the steps for how we do it. So what we're going to do here, and you can pause the video to take down in this example, is we are going to draw the image of the triangle ABC under central symmetry in the point O. Okay, so this is the diagram that we need. Now, yours doesn't have to match mine exactly, but please do use a ruler when we're doing these notes diagrams and try and get it as close as possible. So I've done 4 boxes along here, and then there's 1, 2, 3, 4, 5, 6 blank boxes over, and then 1, 2, 3, 4, 5, 6, 7, 8 boxes up to A, and then just join A to C. In terms of O, if you find where C is, come 2 boxes over and 5 boxes down. That's where I've put O. So if you do something similar to that, yours is going to look the same as mine. Right, okay, once you've done that, how do we do central symmetry? Well, the idea is that we use this point here and we reflect each of these points in turn through it. So we start with the point C, and I go from C to O. To go from C to O, what do I do? Now I can do it by measuring, but we're not going to do it by measuring because that can be a little bit inaccurate if you read your ruler wrong. I came 2 boxes over and 5 boxes down, just like I said to you. So my image on the other side is also going to be another 2 boxes over and 5 boxes down. So whatever I did to get to O, I must do it again out the other side. So 2 boxes over, 5 boxes down, and the image of C, which remember we call it C prime with a dash like that, is over here. So we can just draw a little, you don't have to draw these lines actually, the translation lines, but if you did measure them, you'd see that they're exactly the same distance. So we have 2.5 centimeters to here, and then, oh, they should be exactly the same distance. I didn't line that up right. Yeah, 2.7 centimeters and 2.7 centimeters actually. I should note that I didn't draw that right on the boundary there. Okay. So, same thing for B. To go from B to O, what do I do? So to go from B to O, sometimes it's useful to draw on the line first because then it makes it easier to count the boxes. So I went 1, 2, 3, 4, 5 boxes down, and 1, 2, 3, 4, 5, 6 boxes over. So I must do the same thing here. 1, 2, 3, 4, 5 boxes down, and 1, 2, 3, 4, 5, 6 boxes over. And my point B prime is going to be over here. Let me just label these a bit better. So C prime ended up here. There's my point, and B prime ended up there. Now, something interesting is happening here. These aren't in the same order as I had up here. Let's look at what's going to happen. For the last one then, to go from A to O. So A is all the way up here, and I'm joining it to the point O. It's going to be a lot of boxes to count up, but we can do it. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 boxes over. So we came 12 boxes over there. And make sure it lines up exactly with A. So we count the boxes. How many boxes down did we come? Okay, so how many boxes down? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 boxes down. So I have to do the same thing again. 13 boxes down. You can draw a line and then count them if you like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 boxes down and 12 boxes over. And if you're not sure, you can always count them twice. Thin little line to help me. 1, 2, 3. Oh, we can't see that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes over. So whatever I did, there's my A prime. Whatever I did to get to the point that I'm reflecting through, I must do it again on the other side. Now, finally, we join these together. So C prime to B prime and over to A prime as well. So C prime to A prime and B prime to A prime. Looks like this. Okay, let me just shade in my two shapes to make them stand out. And what do we notice? What's happened to the original shape? It's not the same. When we were doing translations, my original shape always stayed the same. But when I do central symmetry, something happens to the shape. It gets turned upside down and back to front. Okay, so let's write that as a note. This is my object. The object is the starting shape, and this is my image. That's the shape after I've done the transformation. So first of all, we're going to note the image under central symmetry. Central symmetry is always, and let's use some fancy maths words now, is always inverted. Inverted. Spell that right. I-N-V-E-R-T-E-D. Inverted means upside down. And reversed. You probably know what reversed means. Back to front. But area and distance are preserved. They have the same area, it is the same shape, and the lengths of the sides are all the same as well. Area and distance are preserved. Preserved means they're kept. They don't change. Okay, so they don't change. The steps for doing central symmetry, let's write them up here next to our diagram. You can do them underneath if you want. So you, for each vertex, join the vertex to the point, and you have to be given a point for central symmetry. So join the vertex to the point. You can do it by measuring the distance, but it's better to count the boxes. Count how many boxes over and down or up. Sometimes you'll be going up. You went. Do the same on the other side. Same on the other side of the point. And once you've done all of that, join the image vertices together. Remember, vertices are the pointy bits of our shapes. Okay, so very straightforward. That is how we perform central symmetry in a point. So I am going to ask you to practice a little bit with that, and there are some other transformations that we'll be learning as well this week. Okay, thank you.